Today we're looking at the almighty Pythagoras Theorem. Okay, so Pythagoras Theorem, you might probably know the name of it, and you might have an idea that's to do with triangles. And what we'll be using Pythagoras Theorem to do is to find the sides or an unknown side of a right-angled triangle. Who is Pythagoras? Pythagoras was some dude back in, I think it's like 570 BC or thereabouts, who came up with this little theorem, right? So he got a right-angled triangle, and I don't know how he figured this out, but who knows how most of the mathematicians figure this stuff out. It's pretty crazy. But he figured out that if he looked at a right-angled triangle, he measured the areas of the squares of each of the sides. So like basically got this right angle triangle, right? And he put squares on each of the sides. So let's say, for example, that's 4 centimeters. So we've got a 4 centimeters squared, okay? Let's say this is 3 centimeters. That's 3 centimeters squared. He basically figured out that if you calculate the area of these two smaller squares, that it would equal the area of the longest side squared. Okay, so I don't know how he figured that out, but he figured it out. He looked at all these different triangles and figured out they had the same area. So basically, if I added these two together, it would equal the same as that third one. Alrighty. So how does that help us? I guess. Well, let's say, for example, that this is a 3 and this is 4 sided square, and I want to find out what this length is. Okay, now this often we refer to as the longest side of a triangle. We refer to this as the hypotenuse. It's the longest side, I'll write that down. It's the longest side of a triangle, but also you'll notice it's opposite the right angle. Okay, so if I want to find the length of this right angled triangle, well, this is what I said. I said, well, let's find the area of that square. Well, that area is 3 by 3. This area of this square would be 4 by 4. And so Mr. Pythagoras figured out that if I do those two calculations, it will equal the area of this other side. So 3 squared, or 3 by 3, is 9. 4 squared is 16, so that equals 25. So if the area of this particular this particular square was 25 centimeters squared, then what would the side of that square be? Well, hopefully you would recognize that a square with 5 by 5 makes 25. If you weren't sure, what you could do is square root it, and that would give you a length of 5 centimeters. So what I've now been able to find, using the two smaller sides, I've been able to find the length of this bigger side here. Now, with most algebra, they like to use algebraic terms and that sort of stuff to make a general rule. Okay, so let's say I've got my right angled triangle. Mr. Pythagoras said, well, instead of calling it 3, 4, and 5, we're going to call this side A, this side B, and I'm going to call the hypotenuse side C. So the rule that he came up with was this, that if I squared the first one, remember a square is side times side, or A times A. If I added the two squares of the smaller sides together, it would equal the square of the hypotenuse. In other words, A squared plus B squared equals C squared. So we saw before when we looked at that triangle, which was 3 and 4 centimeters long, and we wanted to find out what the unknown was, we would write down the following. We'd write down 3 squared plus 4 squared. In this case, I'm going to use the letter x and make it x squared. On my calculator, I can then write 3 squared plus 4 squared equals, and I'll come up with 25. So 25 is equal to x squared. So what is the opposite of squared? Well, hopefully you said square root. Okay, so if I square root my answer, we get x is equal to 5. And that's my answer. Okay, and that's what Pythagoras theorem will allow you to do. Let's do one more for the easier ones. This time I'm going to use the triangle, let's say 6 meters, 8 meters, and x meters. So how would I find my answer? Well, hopefully we're going to say that 8 squared plus 6 squared equals x squared. We're now going to do 8 squared plus 6 squared on our calculator. We're going to end up with x squared equals 100. And let's square root that answer to get what x is equal to, and x is equal to 10. So you can see it's quite useful to find the unknown side of a triangle. Okay, the unknown side of a right angle. It must be a right angle. If it's not a right angle, guys, we cannot do that question. They do get a bit more challenging, however, which I'm going to look at now. Okay, I'm going to use the 3 and 5 again. So I'm going to say this is 5 centimeters. This is 4 centimeters. So this is going to be x centimeters. Now, you probably recognize that we've used this triangle before and recognize that this will be 3 centimeters. But how do we get it? Via using our Pythagoras Theorem. Well, we know the rule is a squared plus b squared equals c squared, where a and b are the two smaller sides. So I'm going to chuck in for the two smaller sides, the 4 and the x, or x and the 4. So I'm going to put in x squared plus 4 squared equals 5 squared. Now, I don't want to have x squared plus 4 squared. What I want to have is just x squared equals. So how can we get rid of that plus 4 squared? Well, hopefully you said the opposite of plus 4 squared is minus 4 squared. So now we can do on our calculator 5 squared, which is 25, minus 4 squared, which is 16, equals 9. Square root our answer. Remember, we need to find what x is equal to, not x squared. We get the answer of 3, and that's where the 3 centimeters comes from. Some people learn the rule and say that a squared is equal to c squared minus b squared, which simply just means if you have got the hypotenuse, you simply do the hypotenuse squared minus the other side squared. But to be honest, if you remember the a squared plus b squared equals c squared and just change it like we did in that question, it's probably just as easy. Okay, they can give you some fancy little questions too, like, actually if I look at that question again, they might draw this as like a house with, with little windows there and that sort of stuff. And they might say that, that's going to be 4 centimeters away from the house. That's a ladder going up to the house. What's the height of the house? They can draw little pictures. They often like drawing little trees. Having a little tree, having a little person staying away from a tree, and they want to see how high the tree is going to be. So they might say that there's a wire, a 10-meter wire to the tree, and he's standing 5 meters away. So what's the height of the tree? So you're just doing your 10 squared minus your 5 squared equals your h squared, square rooting your answer and going from there. So they can draw little pictures like that to make things a bit more challenging. A lot of time, just redraw your triangle. It's as much easier. The only other question I'm going to give you, and again, I'm going to be using the same triangle. I'm going to use the 6, 8, and 10 triangle, only because I don't have the calculator with me at the moment. So, oops, actually, that's not. I don't want that right angle in there. So what they can do is give a question like this, right? Where they can say that this is going to be 6 centimeters, this is going to be 8 centimeters, and this is going to be 11 centimeters. And they might say, is this a right angled triangle? Okay, and often it will be followed by give reasons or show working. Now, whether or not it says to give reasons or show working, you must do it automatically. Now, if I know it's a right angled triangle, there's one thing that I know. I know if it's a right angled triangle, that if I do a squared plus b squared, it will give me the same answer as c squared, or the hypotenuse squared, because that's Pythagoras' theorem. Okay, so if I'm trying to figure out if it is a right angled triangle, and I'm given all the sides, well, I can just add the 6 squared and the 8 squared together like this, and see what that's going to equal to. Well, that's going to equal to 100, okay, because that's 36 plus 64. I can find out what c squared is equal to, which is my 11 squared. That equals 121. And in this case, that rule does not work out. And I would write that a squared plus b squared does not equal to c squared. Or you might even write 6 squared plus 8 squared does not equal to 11 squared. Therefore, no, it is not a right angled triangle. You know, it's not a right angled triangle. If they gave you the question where it was, 6, 8, and 10, then you could say, yes, 6 squared plus 8 squared does equal 10 squared, therefore yes. So you need to show with working whether or not a squared plus b squared is equal to c squared, and then say yes, it is a right angled triangle, or no, it's not. Guys, Pythagoras is one of the easiest things to do. You need to have your calculator with you, but just go through some questions because it actually isn't that challenging. The only times it can get difficult is when they give you little pictures, or even they might give you a little rectangle like this, for example. They might say that's 8 and that's 4, and they'll ask you to find the diagonal. Which, if you think about the diagonal, if you put a line through, that is actually just a right angled triangle, and you end up doing 8 squared plus 4 squared equals x squared. Square rooting your answer to find out what x is equal to. It's just reading around the pictures, okay? It's not that hard, but you've got to do a few of these questions from your book. Otherwise, it can get a little bit tricky, but honestly, if you do a few questions, this stuff should be pretty easy. Any problems, let me know. You should be pretty good in Pythagoras.